So the next topic of chapter 2 will be models and application. So let's go over some steps that are necessary when solving models and application. So the reason why we call this topic models and applications is because you are not only solving equations from this topic, but also you are building your problem from scratch. Now, in order to build your problem from scratch, you need to first make sure that you understand the problem. The second step is you need to make sure you interpret the problem. Third, you devise a plan. Fourth, you execute that plan. And fifth, you look back, means you check the answers. So to understand the problem, you have to read it. Sometimes reread the problem to make sure that you understand it. In the interpretation part of the problem, you need to not only read it and reread it, but you need to make sure that you can reword the problem in your own terms. Identify necessary information or keyword from the problem that will allow you to work with it. For example, increase. Increase, it's adding something that was a value and a value that is bigger is increasing. That means something is added. For example, if you are talking about um, promotion, for example, you were buying at the supermarket and then something that was costing a certain price, and because of the promotion, it costs such and such percentage less. That's a subtraction. So those keywords are important for you as you are navigating through understanding the problem and interpreting the problem. Third step is to identify the unknown variable. So it's important to look at the question that is asked in the problem because it's going to be the unknown variable in the problem that you're going to identify. You're going to call it either X, T, Y, Z, but once you call it this, you can insert it in a problem, in an equation that is going to be what you're looking for. So the question from the problem identifies the unknown variable of the problem. The question, and it can be more than one, but any question, the question, find such and such. What is such and such? These are the words that you look for to identify the unknown variable that the problem will be solving. A second strategy when you divide a plan is that you sometimes you may want to sketch a diagram, a table, set up an equation, visualize the problem in a simple way that is away from the words that the problem was scripted from. So you bring the problem into something simpler that can be visualized and also solved. You execute the plan is that you solve the equation or you read through the geometrical properties that you have to apply in order to get the solution, but it's from the plan. If you had a shape and we're talking about area, perimeter, and length, those are the things that you're going to look for in the shape that you created, the equation that you set up with the variable that you're going to execute this plan in order to find the solution. And then you check your solutions. So let's go through some examples. Number one, first you need to read the problem and then make sure you read it again to make sure that the understanding is there. It makes sense. All right, so number one, we have the bus fare in a city is $1.25. So I'm going to start pointing out the important information that is in here. Passengers have the option to purchase a monthly coupon book for $21. So a coupon book is also an option for $21. With the coupon book, the fare is reduced to $0.5. So instead, when you combine $21, when you buy the coupon book, then you don't have to pay $125 anymore. You only pay $0.50 every time you take the bus. All right. How many time, how many times in the month the bus must the bus how many times in a month must the bus be used so that the total monthly cost without the coupon book is the same is equal is the same as the total monthly cost with the coupon book. So basically, without and with to be the same. So that means the coupon book, how many times? What's the maximum number of time you can use the, what is the exact value number of time that you can use the bus for having the coupon book and not having it to make no difference. So what do they want me to find? They want me to solve for the number of times to use the bus for with and without coupon book to make no difference. So then I'm gonna I say let X be, so I did two things here. I read the problem, I reread it, and then I'm interpreting it. Let X be this number of time the bus is used in a month. Now, that's the number of time, the X is the number of time the bus is used in a month. Now, if I know the number of time it's used in a month, I can find the amount of the cost of a passenger who did not use the coupon book. So cost without the coupon book. The cost is X is the number of time it's used, and 1.25 is the number if the amount you pay each time you use. So it will be $1.25 times X. That's the cost for a month without using the coupon book. Now let's see the cost with the coupon book. So $21, that this one is a flat fee, $21 plus the 0.5 that you pay every time you use the service. Now, when are they the same? That means when they're equal. So that's 1.25x equals 21 plus 0.5x. So then now we can go ahead and solve this equation to find the x. Remember, x is the number of time you use it. Then they will make the equation make sense. So we're going to subtract 0.5x. So that's 0.75x equals 21. This cancels out. If I divide by 0.75, 0.75, so that's 0.75. So we get x that is 28 times. If we want to check this, um, we can plug in that's 1.25 times 28. That is $35. And then this is 21 plus 0.5 times 28, which is 21 plus 14. That's $35. So that means it makes sense that if you take if you take 28 trips using this type of service, buying the coupon book and not buying the coupon book would not make difference. And that's exactly what they want me to find. They wanted me to solve for these two different options to use the bus to make no difference. And it's exactly when you use it, X, when you use it 28 times. Let's try this next example. In this next example, we might want to sketch a little graph. Let's see what it says. Or sketch a little shape because it talks about a rectangular soccer field. So since it says a rectangular soccer field, you read it and then you reread it, make sure that you can interpret it. A rectangular soccer field is twice as long as it's wide. A rectangular soccer field is twice as long as it's wide. Um, if the perimeter of the soccer field is 300 yards, what are the dimensions? They are asking me for L. The dimensions are L and W. But some information that is given here is that they say it's twice as long as it is wide. So basically, if this is my rectangular soccer field, that's going to be L, and then that's W. It says twice as long as it's wide, so that's 2W. L equals 2 times W, because L is twice W. And then they say the perimeter is 300 yards. So that being said, we can talk about how to find the perimeter of a rectangle. That's um 2 times the length plus 2 times the width, because you add all the sides together to get the perimeter. And then we know that L, we know that L is 2 times the W, so that's P equals 2 times 2W plus 2W. And then we know that P is 300 yards, so that's 300 equals 4W plus 2W, 6W. If I divide by 6, we get W equals 50 yards. And then since we know L was 2 times W, L is going to be 2 times the value we found for W. So L equals 100 yards. All right, so let's go ahead and solve more problems now, uh, based on the practice, the examples that we went over. So first, here we have another practice here that is an investment. Gabriel invested 36,700 into 2 separate investment accounts. One of the accounts earned 1% annual interest, while the other account earned 4% annual interest. If the combined interest earned from both accounts over 1 year was $937, question, and you know the question is where you get your variable or variables. See the question. How much money was invested in each account? So since we had 2 accounts and they asked me how much invested in each account, it indicates that we have we have two different unknown variables to solve for. So then because we have 2 different unknown variables to solve for, I'm gonna call the first one X. Let X be the amount invested in the account that earns 1% per year. And then Y is the amount invested in the account earning 4% per year. Okay. Now that said, we can set up an equation because we have the total. We see, like we anticipate that X and Y are the amounts. We don't know them, but now we can set up an equation with that because we know that the amount invested in the 1% account plus the amount invested in the 4% account, they combine to give me the total money. And the total money was 36,700. So I have one equation that I'm gonna call the total investment. That gives me an equation that's X amount invested to in the 1% account plus Y amount invested in the 4% account combined together is 36,700. So we get the first one. Now let's see if we can find another. So that one is going to be about the interests because they say combined the interest was 937. So we can tell that it's 1% of what was invested, it's earned. 1% of what was invested was earned from the first account. 1% of X is 0.01 times X plus the second account, 4% was earned. So 4% is 4 divided by 100 times the value. So that's 0.04 times Y equals the total earned for the investment. Total earned was combined was 937. So that's 937. So then I have the 2 equations. I can go ahead and solve them because whenever you need to find two values from the equation, you're gonna need the same number of equations to be able to solve it. So um, I don't want to work with the decimal numbers since the numbers have two digits after the decimal, then I can multiply by 100 to eliminate the decimals. So my new investment equation, let me write investment equation. These are the investment. The new investment equation by multiplying by 100 is going to be x plus 4y equals 93,700. So if I bring this other equation down here, I can use the so this is my other equation. I have multiple ways that I can use to solve this equation. So first I can use it by substitution or elimination. I love using elimination. So let me multiply this one by -1. So this cancels the x, -y plus 4y, that's 3y, equals negative 36,700 plus 93,700. That's negative 57,000. So 93,700 minus 36,700. Negative 57,000 because that's positive. It's positive. So we divide by 3 and then we get y equals 19,000. So we get the amount that was invested in the account with the 4% earning per year. So we can just go back to one of the equations, plug in y to get x. So we have x plus the value of y, 19,000 equals 36,700. So x equals 36,700 minus 19,000. 36,700 minus 19,000. So that's 17,700. So x equals 17,700. So here they ask me to give the answers. Y was the amount invested in the 4%. So that's 19,000. And then X was the amount invested in the 1%. So that's 17,700. Okay. More problems here. After a 50% reduction, so that's a subtraction, you purchased a television on sale for $224. $224. What was the original price of the TV? Round your answer to the nearest cent. Okay. So in here, what we see is that there was a price that we don't know yet, and that's what they asked me for. So let me call the original price X. Okay, so now X being the original price of the television and 50% of X was deducted. So reduction of reduction will be equal to 50 divided by 100 times X. So that's 0.5X. So there would be an equation, and after you subtract 0.5X from X, which is the price, you take 50% off, you would get you get to buy the television for $225. So that's X, take away the reduction, 0 point minus the value of the reduction, 0.5X is 224. So 1 minus 0.5 is 0.5X equals 225. If we divide by 0.5, both sides, X will be 448. 20.4. 2024. I mean 224. So X is $448. 448. All right, more problem here. One more problem here. Oh, we got two more. So including 9% sales tax, a hotel a hotel is charging 125.84 per night. Find the hotel's nightly rate before tax is included and round the answer to the nearest cent. Okay, so 9%. 9% is the tax, and 9% of what? 9% of the original price, which is what we are asked to find. So I'm going to call X the original nightly rate. Hotels, the original hotels nightly rate. So with that said, this 80, this 185.84 is the tax, 9% tax, plus the nightly rate, the original 90 rate. So basically it's the original nightly rate X plus 9% of X. 9% of X is 0.09 or 9 divided by 100 times X. So 0.09X, that is 185.84. So combine this, that's 1.09X equals 185.84. And once you divide by 1.09, you get X equals 185.84 divided by 1.09. It gives me 170.4954128. They said that I needed to round to the nearest cents. So then that's going to be these two. Because this one is greater or equal to 5, then we need to add 1. So X is 170.5. All right, one more model example. We have Madeline puts X dollars into an investment with interest rate of 3% per year. So X amount, and then 3% per year. Another account, Y dollars, 11% a year. We remember we solved the problem with investment. It's going to be the same type of problem. She invested in total $4,100. In combined, she earned $339 in interest. From this information, we can create two equations, one for the total investment and then one for the interest earned. State both equations and then solve the system to determine how much Madeline invested in each account. So X is the amount invested in the account that X is invested in earns 3% of X per year. And the second account, Y was invested, and then in this account, 11% of Y is earned per year. But the whole thing is that X and Y combined for a total of $4,100. So that's X plus Y equals $4,100. And then the investment equation will be 0.03x plus 0.11y equals 339. So now that you have these equation, we can solve them to find the investment in each account from Madeline. Well, I don't want to use the decimals, so I'm going to multiply by 100, right? You're going to multiply this by 100, so that's going to be, the first one remains the same, X plus Y equals 4,100, and then 3X plus Y, 11Y equals 33,900. Now that we have these two equations, we can solve by substitution. We can solve by elimination. If you want to eliminate X, multiply the top equation by -3. If you want to eliminate Y, multiply the top equation by -11. But I'm going to use by substitution instead. So that's why I'm going to solve the top equation for X. So X is 4,100 minus Y. And we can substitute X into the bottom equation. So 3 times 4,100 minus Y plus 11Y equals 33,900. So that's 3 times 4,100. 3 times 4,100 is 12,300 minus 3Y plus 11Y equals 33,900. Now we have -3Y plus 11Y is 8Y. If we subtract 12,300 on both sides, so that is 33,900 minus 12,300. That's that equals to 2,1,600, 21,600. Divide by 8, we get Y, which was the amount invested on the 11% earned account. That is 21,600 divided by 8. So that's $2,700. $2,700. And then, so that's $2,700. And then from this equation here, I can replace Y to get X equals $4,100, $4,100 minus $2,700. So 4,100 minus, so that's $1,400. So that's how much was invested in each account based on the conditions described in this book. So this next topic will be about solving equations that has multiple variables, but you are required to solve for one variable. This first equation here is S equals H over M times T1 minus T2. Now, what we are solving for is we want to solve this for M. Solving for M means that instead of S by itself here, we want M to be by itself. Well, since I'm looking at M all the way in the denominator, I'm going to want to move it up. Let's multiply both sides of this equation by M. Well, that allows me to simplify by M. My new equation becomes M S equals H over T1 minus T2. Now, if I multiply both sides of my equation by 1 over S, I'm allowed to cancel that S here, and then I will have M equals H over S times, because the S multiplies all two, T1 minus T2. So M is H over S times T1 minus T2. In the next example here, I have R equals L plus 3W over 2. I like to cancel my denominators, so I multiply by 2 here. So that cancels the 2. And then I'm left with 2R equals L plus 3W. I'm not going to forget that I'm solving this for W, meaning that I want W to be by itself. So I can subtract the L on both sides, cancel the L, and then 2R minus L is 3W. Then we can divide by 3 both sides. We get W by itself, and W is 2R minus L over 3. Or if you want to separate the denominator, each term gets their own denominator. So we would have W equals 2/3 R minus 1/3 of L. Either solution works. Either one is the same thing. I mean, it's pretty much the same thing. You just separate the denominator. Our next example here is P equals 2L plus 2W, which is the perimeter of a rectangle. We'll trying to solve for W. To solve for W, we can just subtract the 2L here on both sides. That cancels that 2L here, so P minus 2L is 2W. And then if we divide both sides of the equation by 2, we get W equals P minus 2W L. That's L, 2L. We get P minus 2L over 2. Or if you separate the denominator, so that's 1W equals 1/2 of P minus L, and either one of the solution. What you can do is you cannot just cancel the 2 here, which will not give you the 1/2 P. It will give you just P. Then you can't do it. You can separate the denominator, give each term its own denominator. Next example here, we have A equals S times 1 minus dn, right? We are solving for n. Now, why what we're solving for is important here is because sometimes we may need to distribute, we may not. If the variable you're solving for is inside of the parentheses, you must distribute. And if it's on the outside and not nowhere in the inside, then you can just keep the parentheses because it helps sometimes. And sometimes you may want to even factor out that variable that you're solving for. And I think the next example may illustrate this. So here we want to distribute because n is what we're solving for and it's inside. So I'm going to have A equals S minus SDN. And I'm solving for n, so I can subtract S on both sides. So A minus S is negative SDN. And we can multiply both sides by -1, so we can get a positive number. So if we multiply, S minus A will be SDN. Then we can divide by SD. So N equals S minus A over SD. Or if you separate the denominators, that's going to be N equals S over SD minus A over SD. Cancel the N, S. So that's 1 over D minus A over SD. Or you can just keep this one. Our next example, we have 2 more, I believe, before the complex numbers. So let's see. For this one, we're solving for K. We're solving this equation for K. 2kx plus 7 equals 9ky. So 2kx plus 7 equals 9ky. So what if since we have k both sides, we're gonna want to retrieve all the k's on one side. So let's subtract, just gonna subtract 2kx on both sides. So that cancels this. So 7 equals, and I can factor k out. So k, 9y minus 2x. Obviously, if you distribute the k back, it would give you the same expression. But since you're solving for k, you want it to be once. You want to see it once in the problem. That's why we factored it out. So now the next thing we want to do is to divide by 9y minus 2x. We divide both sides by 9y minus 2x. Cancels this, then we are left with k equals, so that's not w, that's k, but I don't even need it. K equals 7 over 9y minus 2x. But this one you can't separate. You can only separate when the terms, when you have more terms on top, you can separate the terms with the actual denominator. But you cannot say 7 over 9y minus 7 over 2y. You can't do that here. So you only have one term on top and multiple terms in denominator. So that's the only solution that you have for, only way you can write your solution for this equation. And then the next problem, we're solving for x. We're solving for x, and obviously you see x is all the way inside here and it's over here as well. So you're going to have to distribute the 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 expression that is outside of the parentheses. So we distribute this. That's xy plus 3y equals 5xz plus 4. So now we want to get the x's together and then factor it out because we were solving for x. So let me subtract 3y on both sides. And then I'm going to also subtract 5xz on both sides. So that cancels this one and cancels this one. I'm left with xy minus 5xz equals 4 minus 3y, right? And then now we can factor the x out from the left side of the equation. So x y minus 5z. Obviously, if you distribute again, which we don't want, it would give you the same expression, but we're solving for x, we want to factor it out. So that said, that equals 4 minus 3y. And then we can divide both sides by the coefficient of x, since we're solving for x. Y minus 5z. Y minus 5z cancels this. So x by itself is 4 minus 3y over y minus 5z.